Welcome to a brief video describing the results of FPath Experiment 005. FPath is my project name for experiments on the Feynman Path to nanotechnology. And what is the Feynman Path to nanotechnology? Well, it is the idea that you have large machines make smaller machines, which in turn make smaller machines, and so on, until you reach the point where you can reliably move atoms about at the nanometer scale. Of course, the FPath project is nowhere near that yet. It is still operating on the scale of centimeters, and this particular experiment is only a demonstration of a software technique which may prove useful. But hey, you have to start somewhere. This experiment demonstrates the 2D filling of a space using a technique I call Stigmergic Fill. This video is a follow-on from the results of experiment 004. A link to that experiment can be found in the description below. Before we get into the basic idea of Stigmergic Fill, let's have a quick review of the goings-on in experiment 004. As you can see, the tool head is following a green line. The green line is virtual. It does not physically exist. However, by manipulating the video stream, we can make the software treat it as if it is real. The red circle moves to the nearest green point. As soon as it moves over it, the green point is rendered transparent, ceases to exist, and the software immediately chooses a new green point. Doing this continuously moves the red circle along the path. The line gets followed. The beauty of closed-loop control. What is going on here is essentially Stigmergy. Stigmergy is the modification of the environment to communicate information, and it is a well-known phenomenon in behavioral biology. Since we are dealing with computers, video, and mechanical control, I've named the overall concept Graphical Stigmergy, and we can call the specific case we have just seen Stigmergic Path Following. So, let's extend Stigmergic Path Following and Graphical Stigmergy. Instead of rendering any part of the green path permanently transparent, why don't we just change things around to render just the area the red circle is actually on into a different color? For example, black. Note that the change is not permanent, like it was in experiment 004. As soon as the red circle moves, the green area it was on reappears, and any new green area is rendered in black. So what? Is there a point to such video trickery, you may ask? Well, it is a subtle change, but we can find a use for it. With Stigmergic path following, we could easily see the part of the path we needed to travel over because it was still green. If only the green area the red material is currently on is colored black, we can easily see which areas are not red. In other words, we have a straightforward visual indication of which areas still need to be made red. To make use of this, all we have to do is dispense with our movable red circle and use something more granular and fluid. In other words, the basic idea is that if a red material, red-colored sand in this case, is moved on to a green-colored area, then visible changes to the contents of the screen will provide a simple indication of which portions of the green area are filled. Let's have a look at this in action. In the following video, the green-colored area is virtual. It does not exist. It is generated and injected into the frames of the video feed. The white bed and red sand physically exist. As you can see, when the red sand intersects with the virtual green area, the virtual green overlay disappears and the intersected pixels become black. We can easily see the regions which have not had any sand placed on them. They are still green. And we can also see the areas which have red material. They are still red. It is conceptually a pretty simple operation just to push more red material onto the areas which have not yet received it. Please note, clearly I am manually moving the sand into position by hand. However, you will have seen that in the results of experiment 004, it is quite possible to program actuators to automatically perform this sort of action. All that would be required is to use image recognition to find a red area, then find the nearest green point, and have the actuator push the red material onto the green until the green area is removed and the red is no longer visible. Once that is done, you find the next red, you find the next green, and you keep moving it into position. Repeatedly performing these actions until there is no more green will effectively fill the area with red material. I have not gone to the trouble of actually coding up the actuator behavior for this because of time constraints. I'm pretty sure it can be done. It is just a matter of doing it really. I'm putting some time into other areas of the FPath project and just wanted to do a quick demonstration of this technique for documentation purposes. I call this technique Stigmergic Fill. Stigmergic because the environment is modified to provide signals which control the behavior of the active agents, and fill because the region is filled because of the result of this behavior. How does it work? Well, let's walk through the algorithm. It is really just a variation of the Graphical Stigmergy techniques demonstrated in FPath Experiment 004 for path following. Here is how it works. We have a video feed. This shows us things that physically exist and displays a white bed with some red material on it. In this case, the material is just red sand. Let's call this the original frame. We have a PNG file with a geometric shape which represents the region we wish to fill. This PNG file is read up into memory so that we can repeatedly refer to it without reading it from disk each time. It is stored internally as a bitmap and is 640 by 480 pixels, the same size as the frames in the video feed. Let's call this the area bitmap. The geometric shape on the area bitmap is a simple rectangle colored green. The area bitmap is never visible on the screen. It just forms a backing store. We create a second 640 by 480 bitmap, which is also up in memory. This forms the overlay. Let's call this the overlay bitmap. At this point, it too is not visible. So, for each frame in the video feed, we copy the area bitmap onto the overlay bitmap, thus erasing any previous content the overlay bitmap may have. Then, we check each pixel in the original frame. If we find the pixel is red, we then check the pixel color in the overlay bitmap at that position. If the pixel in the original frame is red and the same pixel in the overlay bitmap is green, then we know the red material is on the green area at that pixel location. In this case, we simply change the color of the pixel in the overlay bitmap to black. This clearly marks that region of red material as being appropriately placed. Once we have done every pixel, we just draw the overlay on top of the original frame. In the above video clip, no red material is in the region of the green area, so the green area appears contiguous. When the red material is moved into the green region, the covered areas change color to black. It is simple to see which parts of the region have not been filled. We just carry on finding red material and filling until there is no more green left. It is also easy to see which areas of the image have surplus fill. After all, they are still colored red. We could trigger an action when there are no more green areas to be found. At that point, we just set the actuators to work sweeping up all the red material, carefully avoiding any of the black colored areas. The other interesting property of the Stigmergic Fill technique is that reality is the model. In other words, if some outside agent disrupts the filled area, the system will instantly detect the area that is no longer filled. There is no need for complicated monitoring solution. It is what it is, and however it may have happened, or whatever the cause, the software can take steps to address it. Let reality be its own yardstick. More and more I'm thinking that control at the micro and nano scales will be much less of running through a sequence of go to this exact point, definitively do that type operations, than a general this needs to be done, activate events which should cause that to happen, and monitor the reality to see what you get. The unavoidable errors and lack of precision will make perfect control hard to obtain. Well, that's the technique of Stigmergic Fill. I just thought you might be interested to see it. Thanks for watching, and see you next time.